Okay, in this video, I would like to go over questions 6, 7, and 8 from the test 3 review. Okay, so it's going to say identify the vertex, the axis of symmetry, and the two x-intercepts. So it's telling you there are two x-intercepts. We're going to put the vertex here. We're going to put the axis of symmetry. That's supposed to be an x right there. And we're going to put the x-intercept here, one of them there, and we're going to put one of them here, okay? And we're given a quadratic function in vertex form, okay? So we can identify vertex form because we have like an x plus or minus something, and then it's in parentheses, and then it's to the second power, and then we have plus or minus a number out here. And this indicates that the vertex of this, so this first thing we're going to identify, the vertex is always the opposite of this number, so the opposite of positive 5 is negative 5, and then the y-coordinate is what you see here, minus 9. So the vertex is negative 5, negative 9, just by looking at this, okay? And again, the way that we got that was we just did the opposite of this for the x-coordinate, and we did this for the y-coordinate. So the vertex is at negative 5, negative 9. Now we can only do that when the quadratic is in vertex form, okay? All right, and then we want to identify the axis of symmetry, and the axis of symmetry is always x equals the x-coordinate. X equals negative 5. So look at that. We are halfway done. Now we want to identify the x-intercepts. Now the x-intercepts are going to take a little more work. So let me give myself some space here. In order to identify the x-intercepts, there's a couple ways to do it. We could extract square roots by taking this and setting it equal to 0. So maybe we'll do that. We can do x plus 5 squared minus 9 equals 0. Then we'll add 9 to both sides, add 9. And now we have x plus 5 squared equals 9. Now what we're going to do is we're going to take the square root of both sides, and we wind up with x plus 5, because all it's going to do is going to cancel this square right here, okay? And all we're going to have left is the x plus 5 equals, the square root of 9 is 3, but we have to do plus or minus 3 when we're doing quadratics because we can include negatives. Now what we're going to do is we're going to subtract 5 from both sides, and here's what we wind up with. X is equal to, we usually write the negative 5 first, minus 5, then we'll write our plus or minus 3, plus or minus 3. This is actually two answers. We have negative 5 plus 3, and negative 5 plus 3 is negative 2. So one of our x-intercepts is negative 2. And then we have negative 5 minus 3, which is negative 8, so our other x-intercept is x equals negative 8. Now I'm going to show you one other way that we can do that. That way, in my opinion, is the easiest way to do it. But now we're going to do it a way that's a little bit harder, but the way we're going to do it right now, it works every single time. You won't hit any snags if you do it right. Okay, now another way that we can do this is we can expand the vertex form. So we'll take our x plus 5 squared minus 9, and that's going to be equal to x plus 5 times x plus 5, and then it's minus 9. And then if we expand that, this is going to be x times x is x squared, x times 5 is plus 5x, 5 times x is plus 5x, and then 5 times 5 is 25, and then minus 9, okay? And now we combine these, and we get x squared plus 10x. Then we combine 25 and minus 9, and we get plus 16. We're going to set this equal to 0 so that we can find our x-intercepts. And now this, we can either do the quadratic formula, where a is 1, b is 10, and c is 16. Now I'm not going to go through that, but I'm confident that if you know the quadratic formula, you can go ahead and do the quadratic formula with these numbers. What I'm going to do instead is I'm actually going to factor this. I'm looking for two numbers that multiply to 16, but they add up to 10. And those two numbers are positive 2 and positive 8. And if I put an x in front of each one and then put parentheses around them, I've now factored this into x plus 2 times x plus 8. I set that equal to 0. And then I set each one equal to 0. X plus 2 equals 0, and then x plus 8 equals 0. Subtract 2, and I get x is equal to negative 2, just like this down here. Subtract 8, and I get x is equal to negative 8, just like down here. And I've identified both of my x-intercepts. All right, now we're going to identify the same things, the vertex, the axis of symmetry, okay, and both x-intercepts, okay? So it says identify the vertex, the axis of symmetry, and the two x-intercepts. But this is not in vertex form, this is in standard form. And so to find the vertex, we're going to have to identify the x value of the vertex. And the x value of the vertex in standard form is equal to negative b over 2a. So let's go ahead and identify a, b, and c here. A is negative 1, A equals negative 1, B is 2, B is equal to 2, and C is equal to 15. Oops, that's a pretty ugly 15 there. There we go. And so now, to find the x value of the vertex, I need negative b in the numerator. Well, b is 2, so I'm going to put negative 2 in the numerator. And I need 2 times a in the denominator. Well, a is negative 1, so 2 times negative 1. So now I have negative 2 over negative 2, and negative 2 divided by negative 2 is 1. So I know that the vertex has an x value of 1. Now to find the y value of the vertex, I need to plug the 1 in for x in here and here. So I'm going to do negative 1 squared plus 2 times 1 plus 15. And let's do 1 squared first. Don't do this negative. That negative is not inside. It's not in there. Let's do 1 squared. 1 times 1 is 1. Then we're going to do the negative of that, so that's negative 1. 2 times 1, so plus 2, and then plus 15. Well, negative 1 plus 2 is equal to 1, and then 1 plus 15 is 16. So the vertex is at 116. Now we're going to do the axis of symmetry. I really hate that I put a V here. That's supposed to be an X, axis of symmetry. Okay? And remember, the axis of symmetry is a vertical line, x equals, and it's whatever the x value is of the vertex. So the axis of symmetry is at x equals 1. Now we're going to do the x-intercepts. Okay? And I think since we already have a, b, and c, let's go ahead and do the quadratic formula. Okay? Let's make some space here. We'll erase all this work. And we know that the quadratic formula goes x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Now I would go ahead and put this quadratic formula on one of your lesson sheets that you're going to have with you during the test. That way you have the quadratic formula with you during the test. Okay? So let's do x is equal to negative b, and b is 2. So it's going to be negative, and then b is 2, plus or minus the square root of b squared, so that's 2 squared, minus 4 times a is negative 1, times c is 15, all over 2a, and a is negative 1. All right, so let's clean this up. We have negative 2, so negative 2 plus or minus the square root. 2 squared is 4. Negative 4 times negative 1 is 4. And 4 times 15 is 60. So this is going to be plus 60 all over 2 times negative 1 is negative 2. 4 plus 60 is 64. So we have negative 2 plus or minus the square root of 64 over negative 2. And the square root of 64 is 8. So it's negative 2 plus or minus 8 over negative 2. So one of our answers is going to be negative 2 plus 8 over negative 2. So let's do that up here. negative 2 plus 8 over negative 2. Well, negative 2 plus 8 is 6. 6 divided by negative 2 is negative 3. So one of our x-intercepts is negative 3. Now we're going to do negative 2 minus 8 over negative 2. So negative 2 minus 8 over negative 2 is negative 2 minus 8 is negative 10 over negative 2. And negative 10 divided by negative 2 is 5. And so our other x-intercept is positive 5. I want you to know also that this is factorable if you factor out a negative 1. So if you factor out a negative 1, this will then become factorable. But this will have to go away, this will have to become a negative, and this will also have to become a negative, and then you can factor it, okay? All right, let's try question 8. All right, so this one says that there's a parabola, that means it's a quadratic, and it has a vertex 4, negative 5, and it passes through the point 2, 3. And we want to write the equation in both vertex form and standard form, okay? Well, we're going to start with vertex form. We know that we have a vertex of 4, negative 5, and therefore we know that the function f of x is going to be equal to, and the vertex form is a times x minus h squared plus k. Now in this case, h is 4, k is negative 5. So we're going to rewrite this as f of x is equal to a times x minus 4, because h is 4 squared, and then plus k. Well, k is a negative number, negative 5. So we're going to put minus 5, okay? All right, so now we just need to solve for a. Well, how are we going to solve for a? Well, what we're going to do is we're going to take this 2, this x, this is an x, and this is a y. But y also means f of x, okay? So we're going to put, really it's not f of x, it's actually f of 2 is what it is, because the x is 2, okay? So we're going to put the 3 here, and we're going to put the 2 here. So we're going to have 3 is equal to a times 2 minus 4 squared minus 5. And we're going to solve for a. Well, 2 minus 4, so I'm going to rewrite this over here. 3 is equal to a, and then 2 minus 4 is negative 2 squared, and then minus 5. So now 3 is equal to a. Well, negative 2 squared, negative 2 times negative 2 is 4, and then minus 5. I'm going to rewrite this. I'm going to write it as 3 equals 4a minus 5. Now I'm going to add 5 to both sides to solve for a, and I get 8 equals, these cancel, 8 equals 4a. And so now, 8 equals 4a. I'm going to divide by 4 on both sides. 8 divided by 4 is 2. Cancel the 4's, and a is equal to 2. And therefore, this is a 2. This is a 2. So this is our vertex form, but we're going to put a 2 in for a. So f of x, vertex form is f of x equals, instead of the a, we're going to put a 2, then x minus 4 squared, and then minus 5. So there's our vertex form. Now to find standard form, all we're going to do is expand the vertex form. And so in order to do that, I am going to make some room. I'm going to erase some stuff, okay? All right. You may need some scratch paper when you take the test for a question like this. All right, so I'm going to take the 2 times x minus 4 squared minus 5. Now I'm going to expand this. So this is now going to become 2 times x minus 4 times x minus 4, okay, minus 5. Now x times x is x squared. And I got to put this in parentheses because I have the 2 on the front. X times negative 4 is negative 4x. Negative 4 times x is another negative 4x. Negative 4 times negative 4 is plus 16. And then I'll close the parenthesis and put the minus 5. Now I'm going to distribute the 2. 2x squared, 2, and I have to combine the negative 4x. That's going to become negative 8x. And negative 8x times 2 is negative 16x. You know what? Let me go back. Let me back up here. Let me add an extra step, okay? I'm not going to distribute the 2 yet. I'm going to combine the negative 4x. So I'm going to have 2 times x squared minus 8x plus 16 and then minus 5. Now I'll distribute the 2. 2x squared, 2 times negative 8x minus 16x, 2 times 16 plus 32 minus 5. And so now my standard form is f of x equals 2x squared minus 16x, and then I got to do this 32 minus 5, which is 27, so plus 27, and this is the standard form of this quadratic, okay? And that's it for question 8.